Presentation of paper ID number 29, title Joint Position Detection for the Elderly Exercises using Backpropagation Neural Network. The agenda will go to 7 topics. The first one is abstract, followed by the problem statement, system framework, implementation, results, concluding remarks, and will be ended by the future works. The inspiration of this work is based on the limitation of elderly movement. The lack of monitoring while the elderly is doing the exercise may cause the injury. The system can prevent the injury of the elderly by real-time detecting and alerting. The video clips of the elderly exercises used in this system, created by the sports science specialists from Thai Health Promotion Foundation. There are 2 modes of exercise, sit mode and standing mode. The elderly may prompt to see the demonstration of each exercise from the video clip on the GUI. The Kinect extracts the joints during the exercise, and the system will alert if the wrong posture of exercise is detected. Our method uses the backpropagation neural network for training and testing models. The 16 exercises of the elderly were recorded and extracted into 8,300 frames in total as the training data. We generate the model of the exercise number 1 by using 500 frames. For the example, our 16 models use 25 hidden nodes in the second layer and 2 outputs. In the real-time classification, the system yields the result of 79, 77, and 79 of precision, recall, and F1 score respectively. Exercise may countless benefit for all ages, especially in the elderly. You may know that the research work also shown the elderly walks 3 or more times a week. The occurrence of dementia will be reduced lower than 35% compared with the elderly that who do not involve any type of the physical activity. Unfortunately, the elderly muscle can be decreased by the age. Therefore, the limitation of the elderly movement is the major concern. Leaving the elderly do the exercise on their own may cause the injury. The paper presents joint position detection for the elderly exercises using backpropagation neural network. By the real-time monitoring, the system can prevent the injury of the elderly by detecting the elderly pose while they are doing their exercises. The system will alert to the elderly or the caregiver whether they do the wrong poses to prevent the injury of muscle and joints. We selected the video clip of the elderly exercises created by the sport science specialists from Thai Health Promotion Foundation. The exercise consists of 2 sets, the sit mode and the standing mode. In the sit mode, they consist of 12 exercises. The elderly can do their exercises by sitting on the chair and follow the instruction on the video clip. In the standing mode, this consists of 4 exercises. The elderly can do their exercises using the chair to assist while they are moving the part of their body. For example, raising their left or right knee. The Kinect is the depth camera using the infrared rays to extract the human joints into the low-level feature. The Kinect camera can be captured three-dimensional video with a frame rate of 200 frames per second, and the highest resolution of the Kinect is 1280 plus 960 pixels. The C direction in the three-dimensional axis is the distance of the depth distance between the human body and the Kinect camera. The appropriate distance between the object, which is the human body, and the Kinect is between 1.8 to 3 meters. The left one of the picture is shown the Kinect camera, the object, and the skeleton extraction. And the table in the right is the example of the skeleton extraction of the 4 exercises in the sit mode. Our system framework has one hidden layer and 25 hidden nodes in the second layer, and it generates 2 outputs. We use 1 model per 1 exercise. The table 1 shows the number of frames used in the data preparation. The total frames of the 16 exercise, we use 8,300 frames as the training dataset. As you can see that in the exercise number 1, this consists of 500 training set of frame, and exercise number 16 is we use 350 training set of frames. In the implementation, we designed the GUI with the low fidelity concept to capture our idea into the testable artifacts and use for the assessment to the caregiver or the elderly, and we redesign and use the feedback of the user to finalize the final GUI. The left one is the low fidelity design, and the right one is the final product. The GUI consists of 2 main windows. In the left, you will see the video clip from the sport science specialist, and they demonstrate how to do the exercise. And the right window is the skeleton extraction. The symbol below here is the alert symbol. If the user do the long pause, they will be shown the signal is the correct signal, and cross defined is by the wrong pose respectively. The result based on the proposed method. We give the 3 parameter to asset our model, the precision recall and F1 score. Our proposed model can classify all 16 exercises. It will give 79, 77, of the average precision and recall, and it gives 79 of average F1 score. The result uh, of the evaluation shown in this slide. We can conclude that the accurate result and the model loss of our proposed model yield around 0.7 of accuracy in the 1,250 epochs, and the model loss is around 1.0 as shown in the figure. In the future works, we plan to develop the classification method by using the CNN. The CNN is the deep learning model, and this is the alternative version of the multi-layer perceptron. They can take advantage over the multi-layer perceptron since the CNN have the pattern like the hierarchy pattern in data and can be assembled more complex pattern using the smaller and simple pattern. We also plan to develop our modified classification method with another type of exercise, which is the Tai Chi exercise by using the two Kinect camera. The camera will be can be capture more precise of the skeleton structure by two Kinect camera instead of only one camera in our first version of experiment. Thank you.